As science begins to work with smaller and smaller objects, the community is challenged by the need to enumerate and characterize these particles. By harnessing natural processes, we can produce devices that let us interact with tiny objects. Devices called biosensors utilize innate electrochemical processes in cells to produce an electrical signal proportional to concentration of a particular molecule. Biosensors can be simplified into three main modules: a biological recognition component, a transduction unit, and signal processing circuitry. The most important part of the sensor is the biological recognition component. This is the part that actually interfaces with the molecule we want to look at. Thankfully, Mother Nature already has her ways to accurately differentiate between molecules. Proteins called enzymes assist cellular processes by binding molecules during chemical reactions. The binding sites of these molecules are individual to the molecule they bind, like puzzle pieces, allowing the enzyme to select for a single molecule out of hundreds that might be present. Certain types of enzymatic reactions, called oxidation reactions, result in the release of one or more electrons from the molecule bound to an enzyme. Electrons are negatively charged particles, and their flow results in the phenomena commonly known as electricity. By directing the flow of electrons from the enzyme molecule complex, we can generate an electrical current whose magnitude will be directly proportional to the rate of oxidation, and therefore proportional to the concentration of the molecule of interest. Once we produce electrons, we need to shuttle them from the enzyme to the probe. Small units called electron mediators that temporarily hold electrons pick up the electron from the enzyme and pass it to the transducer. This conductive transducer then sends the electrons to signal processing circuitry that amplifies and reduces the noise of a signal, making it easier to use. The computer now acquires the signal and with some fancy calibration equation turns electrical data into concentration data. Biosensors like these have all kinds of potential applications. Sensors for glucose can be used to test blood sugar levels in diabetes patients or energy content in biofuels. Biosensors can also be used to look for pesticide contamination in groundwater or for penicillin contamination in milk. These sensitive and specific tools have the potential to change the way we interact with the microscopic world. Science gets smarter when we listen to nature.